Hello everyone. So today we're going to be understanding what trees are, tree data structures, and how they function, what all basic terminologies that they have, and what those basic terminologies mean. So this is an introduction to trees video, and we are going to be understanding how the tree data structure works. So basically, as the name suggests, tree data structure resembles a real life tree. So as we know, a real life tree is built like this, but a tree data structure can be thought of like this, where here at the top is the root, then there is the other nodes, and then there are also leaves, right? So a tree data structure functions something like this. So in definition, tree is known as a non-linear data structure, and it is a non-linear data structure in which items are arranged in a sorted sequence in an ideal tree. In an ideal tree, right? It is not the case for all the trees, but it is an ideal scenario. And it is also a hierarchical data structure which stores the information naturally in the form of a hierarchical style. So a tree is basically built something like this. So as you can see, there is some sort of a hierarchy. And this hierarchy is basically used to store the data in a hierarchical form. What are some examples of hierarchical form? We have seen hierarchical data structure storing in file systems when we store some files under a big folder and then that folder under some other folder. We're basically storing it in a hierarchy. Right? So now let's come to the technical terms of a tree. So now let's take an example tree, right? Okay. Okay, so this is the tree I've taken, and I'm going to explain all of the technical terms to you in terms of this particular example tree, right? So now let's come to the terminologies of tree. So the first thing that we're going to learn here is the root. Root is the point or the node where the tree starts. So this obviously root of this tree is A, from which other nodes arise. Other nodes are connected, but there is nothing connected. Uh, the root node is not coming from anywhere, is not getting derived from anywhere. It is the starting point of the tree. So this is the root node, right? The next thing we're going to learn is the terminal nodes and all other nodes. So basically nodes. So all the points in a tree, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are the number of nodes in the tree. So A, B, C, D, E, F, G, H, I, they are all the nodes of this particular tree. And now let's come to the type of nodes. There are two types of nodes. There are terminal nodes and there are non-terminal nodes. So terminal nodes here are the nodes which basically end, and they don't have any children, they don't have any other nodes coming out of them or any subtrees that are being derived out of them. So these are terminal, they terminate. So E, F, G, H, I, and C are all the terminal nodes, right? So we can list them as terminal nodes. And the terminal nodes are also called one more thing in common language. They're also known as leaves. So we can say E, F, G, H, I, C. These are all the terminal nodes or also leaf nodes. Just like a tree, it ends at a leaf and then that leaf can be plugged. These are the terminal nodes, right? Then we come on to our non-terminal nodes. Non-terminal nodes, as the name suggests, are the nodes which are not terminal. So obviously B, D, and A are the non-terminal nodes in this particular scenario. A, B, D, which have basically something coming out of them and something that is being derived out of them. So for example, from A, we can see B, C, and D being derived, and from B, we can see E and F being derived, and then from D, we can see G, H, I being derived. So these are all the non-terminal nodes. Now let's come to our degree of the tree and degree of these nodes. Degree of these nodes are basically how many nodes are being derived out of them, right? So certainly a non-terminal node will have a degree of 0 because nothing is being derived out of them. So we can obviously say that for A, B, and D, there would be some degree, and that degree would be its number of children. So A, the degree would be 3. For B, the degree would be 2. There are 2 children that B has, and then 2. And then D would also have a degree of 3 because of G, H, and I. So A, B, and D have a degree of 3, 2, 3, and C, F, E, G, H, I will all have a degree of 0. Okay. Now let's come to the degree of this tree. This entire tree has the degree of the node which has the highest degree. So we can see for this particular tree, A and D have the highest degree, which is 3. So degree of this is equal to 3. Why? Because A and D have the highest degree. Now let's come to our next topic, which is siblings. Now it might be a little obvious that siblings are the nodes which are coming out of the same parent. So here, whenever something is being derived out of something, so for example, X node has 3 children, right? W, Y, and Z. X is the parent node, and W, Y, and Z are the child nodes, right? Because they are hierarchically lesser than the parent node. So obviously, these are the children node. So when we talk about siblings, they are all coming from the same parent, right? So B, C, and D, you can see, are coming out of the same parent. So they can be obviously called as siblings. So what all sibling combinations can you see here? You can see B, C, D. You can also see a combination of E and F because they are coming out of the same parent. And then you can also see G, H, I, right? So these are all the siblings that you can see in the tree. Now, obviously, parent is the parent of those siblings. So A is the sibling, A is the parent of B, C, and D. B is the parent of E and F. A, B, and D is the parent of GHI. Okay. Now let's come to our next topic, which is levels. Levels are the degrees of those trees. So basically, when these 3 and these 2, these are said to be on the same level because there have been 2 derivations since the root node to reach here, right? So A derived B, B derived E and F, A derived D, D derived GHI. So these are 2 derivations, same number of derivations. So these are all on the same level. So this level is basically, now let's start from the topmost level. So as we can see, A is on level 0, B, C, D are on level 1, and E, F, G, H, I are on level 2, right? Just let's take a fresh look at this. B, C, Right. So this is our level 1, sorry, level 0. These three are on level 1 and these 5 are on level 2. Great. Now that we're done with our levels, now let's come to our edges. They're very easy. There's nothing complicated about edges. So edges are basically just the lines that are connecting the parents to the children, and these are the edges in this case. So these edges are usually represented in the form of tuples. So AB is an edge, then there is AC is an edge, AD is an edge, and so on. BE is an edge, and there can be multiple edges. Now, for an ideal tree and for a good tree, we can see that the number of nodes, if the number of nodes is n, nodes is equal to n, then the number of edges would be n minus 1. And why is it so? Because obviously the number of edges would be connected to the nodes as well, but there is no edge that is coming towards A, right? So coming towards the root node, there is no such edge, therefore minus 1. So n minus 1 is the number of edges in a tree. Now let's come to our one more property of this tree, which is usually called as recursive nature. So as we have already seen that for a tree, one node is deriving two nodes, but it is not necessary that these two nodes that it is deriving are just nodes. They can be trees as well. So it's safe to say that A is deriving B and C, but these B and C are actually subtrees. So this can be something like this, and this can be something like this, right? There can be any such scenario. So these are all trees in itself, right? So this is the recursive nature of a tree, that a node derives subtrees, and those subtrees, and inside those subtrees, obviously, another node derives another subtree, and so on. Now, the next thing that we're going to discuss is a path. So, path is the way or the path of reaching the desired node from the root node. So as we can see in this scenario, for example, I have to determine the path of A to I. So the path would be A to D and then D to I. So this is the entire path of me reaching I from A, right? So this is called the path of that tree. So path of that particular node in that tree. So now let's come on to our next topic, which is a forest. If in a tree I remove the root node, I would be left with B, C, D, E, F, G, H, I. I'm just left with a number of trees. There is nothing connecting them. So these are just a bunch of trees. And when there are a bunch of trees lying around, they're known as a forest. As simple as that. So they're all trees, nothing common. So there's not one tree, it is not one tree, they are not the subtrees of one tree, but there are different trees altogether. So these are known as forests. And obviously, if we talk about the depth, right? So depth of these nodes, the two important concepts in measurements will be depth and height. So when we talk about depth, depth is nothing but the distance from the root, and height is the distance from the bottommost leaf node of that particular tree, right? So if we talk about A, the height of A is not 1, not 1. The height of A is 2. Why? Because I is the maximum sub node that it can derive, and that is the maximum height. So A has the height of 2 and depth of 0. Why? Because from the starting, it is it is the first node that comes, right? So if this tree were submerged underwater, it has zero depth because A is just below the surface, it's just beneath the surface of water, right? So now let's come to B. B has a height of, obviously, it has a height of 1 because that is the maximum it can go, and it has a depth of 1 again, right? Because that's one unit from A as well. And if we talk about I, it has a height of 0. So, yeah, it has a height of 0 because there's nothing from the ground. And if we talk about depth, depth is 2. Okay, so these were all the concepts that we need to know about a tree data structure and how it functions. And in the next videos, we'll be covering the different types of trees, binary trees, and all the different varieties that we can have in trees, and the traversal algorithms, what all for functions that we can perform in a tree. So stay tuned and keep learning. Bye bye.